Okay, welcome back again. Come to workshop once again. So last tutorial I did something on itching and latching operation, and I showed you the difference between the both of them. And I promise that in this tutorial once again I'm going to bring timer, delay timer, to spice up that operation. So in the latching operation, you saw what happened there. By the time I press the push button, the motor continues to run, and by the time I stop, I press the stop button, it stops. In the itching operation, I press the push button. As I'm removing my hand, the motor just stopped. So these are the difference between both of them. So now on timer is when you press the push button, it activates the timer, and after some seconds, depending on your timing, 1 minute, 2 seconds, depending on your timing, the motor starts. So that is it. It's just a timer, it's just to time the motor starting period, starting time, sorry. So now I will use this timer. For example, here I will use this timer. Let me come very close so that you will see it. Okay, so now I have the base here. The base is an 8-pin base, and so this is the cheapest timer you can get in the market. So before I showed you an Enters timer. That's very expensive. It's very expensive. It's somehow expensive for practical purpose, for learning purpose. I don't think you going to make use of this one, because this one is 12 to 240 AC DC, so it's very long range. It accommodates a very long range with it, so you can use it on 24 volt supply, DC or AC, 12 volt supply, DC or AC, 18 volts, 48 volts DC or AC, so, and the 120, 110 AC or DC, and 240 volts AC or DC. So it's a flexible timer. This intense timer, that's a Turkish timer made in Turkey. Okay, so it's expensive. Look at the carton. Let me show you. You see MCB8. So this is the carton of this timer. Okay, so the Anley timer, look at the carton of the Anley timer. So that is it. So I'm just showing you all these things. What I'm showing you is just for you to see the picture of what you are working with, how it looks like, so that when you go to the market to get your own, you already know exactly what you are looking for. So getting to the market, they will just bamboozle you. All those guys in the market will just bamboozle you and just give you whatever they have. And so if you know what you have, you work, you go for it and just get what you want. Okay, so as simple as ABCD. So I'm going to, I've introduced the timer in the circuit. So let's go to the circuit board. Let's see what I've introduced, and then we'll go to the practical board. Then we'll practicalize it. Then at the end of this operation is just for you to delay the motor starting period. So once you click the start button, you wait until the timer counts. Depending on the set point of the timer, the motor comes on. So after, what are the practical application of all these things? It's just on circuit board. What are the practical application of all these things? Okay, let me just give you a practical application of all these things in refrigeration. For example, in refrigeration system, whereby you have an evaporator motor, then you have a condenser motor, then you have a compressor. They are all motors. So you have 3 motors. The compressor, there's a motor turning the compressor inside. Inside the reciprocating compressor or screw compressor, there's a coil, there's a motor inside. So I'm seeing the compressor as a motor now, not as a mechanical device. Then I'm seeing the condenser fan motor as a motor, not as a fan. Then I'm seeing the evaporator blower as a motor, not as a blower, because all of them, there are motors inside. Okay, now you have 3 motors. Now refrigeration is a refrigeration cycle is a sequential system that works with a sequence. So first of all, you know that before the compressor starts, the AHU or the evaporator must be on. So now the evaporator starts first. After some time, maybe 3 minutes or 5 minutes, depending, I think 5 minutes is the standard, then the compressor starts. So that counting of 5 minutes, what does the counting for you? It's a timer that does the counting for you. So the timer counts. After what? After 5 minutes, after 3 minutes, it kicks up the condenser and the compressor starts immediately. In some occasions, you see even the condenser fan starts a minute before the compressor picks up. So you have two timers, one counting for evaporator, one counting for condenser, and one counting for compressor. So immediately you press the push button, the evaporator starts. Then after some maybe 3 minutes, the condenser fan picks up, then follows by compressor. So you find out that in industrial application, timer is very, very important. They use timer to start up a sequential system, a system that starts in sequence. So you use a timer to start up a sequential system. So now in this practical that we're doing is applicable to every field. So once you get to a sequential system that you need them to start in sequence, you use delay timer or use a delay system to delay the process at which the system comes on. So timer is very, very important. So that's why we're introducing this timer. It doesn't look as if say that they are not. They are very, very important in motor control. So timers are very important in motor control. In some mixing applications whereby the motor mixes up a substance, maybe a paint or turns up something, so you need timer. So in so many things you need timer. In so many applications you need timer. So you use the same principle, you apply it to whatever field you are making use of the operation, the motor control operation. So okay, so let's go back to the circuit board. There's no too much preaching and talking in evening service. Let's go and practicalize it and see how it goes. So I connect, these are my connections. I drew with pencil, so but you might not see it. So because of the reflection of light, I'm using white paper. Supposed to use a colored paper, maybe use a yellow paper so that you can be able to see it very well. Maybe next time I'll try a yellow cardboard or a male color cardboard so that you can be able to see very well. Okay, so now because the reflection of light is making it difficult for you to see the pencil, but I will use a permanent marker to highlight them. So now let's go. We are using line 3. Okay, so let's connect to line 3. It goes. Okay, so this is it. Okay, now it gets to the fuse. I have my fuse, which is F1. Then from fuse gets to overload, 95, 96, which is F1F, my F1F. Then it drops down to the first switch, which is my X0. That is my off button switch, which is 1 and 2. Then it goes down again to the second switch, which is my S1. Okay, now it goes down again to the A1 and A2 of my timer, which is A2, which is neutral, then goes to the neutral bar. This is my neutral bar, which is also represented here. So you can link, which is also represented up there. This is a neutral bar. Okay, so I'll use blue here. So this is my neutral. Now this is A1 of my timer, A2. This is KIT, meaning timer. I'm representing it with KIT. Okay, so this is how it flows. Now, the timer, we have to sustain the timer with its own contact. So I have 3 and 4 as normally open of this timer, of this only timer. The 3 and 4 comes on, immediately the timer comes on, it just closes immediately. It's not timed. So 6 and 8 and 6 are timed. So on this is time. Why this is not time? On only timer, I'm using only timer, this only timer. So mind you, I'm using only timer. This is not time. This contact is not time. It's garbage in, garbage out. Immediately the timer comes on, this contact comes on. This contact comes on. So let me show you. So this is 3 and 4 of this switch, which is normal open, and so KIT. This is 3, this is 1. Okay, so now this is what goes on here. So this guy here is not timed. It's not timed. So this guy is not timed. So immediately this timer comes on as you push your switch from your on button switch. It powers the timer. Goes through down here, past the overload, past the fuse, the timer comes on. Once the timer comes on, this contact gets closed immediately without timing. So the 3 and 1 of only timer is not what? It's not timed. So it closes. Once the coil closes, this guy closes. So as it closes, you are removing your hand from the switch. It sustains. It sustains the circuit. So it passes through here and sustains the timer for the timer to keep on counting. So this sustained contact is for timer. It sustains the timer now. As it's sustaining the timer is counting. After 10 seconds, the timer kicks on. So the 6 and 8 of the timer comes on to power what? The contactor. K1. So let's do it. So now I go like this. KIT 6 and 8. Okay, if you have a question, you can ask me on a comment section. I will be there to answer you, or you send me a private chat. Inbox me A1, A2. So this is 7 and 2. Which is the coil contact of this timer, 7 and 2 of the only timer and still timer. They are the same. Only timer or still timer, they are the same. So when we use enter timer, I will also give you the details of their contacts. Okay, so now this is 7 and 2. So you have the 2 as your neutral, you have your 7 as your live. This is a 220 volts timer. Mind you, our control is 220. So this is 3-phase. We're using 400, 380, 400 volts. Then by single phase, we're using 220, 240 volts. Okay, we are not using 110, neither are we using 24 volts. Okay, so that is it. So everything we're using is 220. Our control is 220. So all the components here are 220 volts control, 220 volts rating. Okay, so that is it. So now you have seen now. Mind you, our main circuits remain the same, both on the 3-phase side and the single-phase side. Our main circuits remain the same. What changes now is the control, because this is the control that powers the main. The control powers the main. So now our control circuit is where the changes began. Remember, I just used this to cover what we have done before. It's just a paper, I covered it. The other one is binetted. Look at it, it's binet. It's just binetted. So it's the same thing. So now, this is how it works. Once you power the circuit, you press your push button switch, power goes from here, enters, goes straight and power the timer. As it powers the timer, this contact closes and it sustains this timer. It goes like this, goes back. It goes back like this to sustain the timer. When the timer is sustained, by that time you have removed your hand, because this thing happens in a split of a second. The speed of electricity is very fast, so it happens in a split of a second. So it's faster than the speed of the speed of light, the speed of sound and light and rest of it. So it's faster. This electricity is very fast. So by the time you press it, everything has, in a split of a second, everything has taken place. So immediately it sustains the timer, and the timer keeps counting, and it's on. It keeps counting. It keeps counting. Maybe after 10 seconds, depending on your set point, bam, it switches this contact on. This contact comes on. This relay on this timer comes on. This is a relay contact. This is a relay contact also. But this is not time, this is time. So relay contact on this comes on. So you have to understand the configuration of your timer. So this, based on the configuration of this timer, This is how I figured it out. Okay, so some other timers, you have all of them, they are being timed. So you have to find a way to find something to use to sustain the circuit. Maybe you introduce another additional relay to sustain the timer, or there must be an additional relay in the system. There must be an additional relay in the system to help you to sustain the timer for the counting. Okay, or the timer just comes on. You don't need to sustain the timer. You wire it directly, and you know how to do that one. I don't know. Okay, so depends on your operation. So this is my own operation. Okay, so where are we now? Okay, so now immediately this guy comes on. It powers this contactor, which is K1, and the K1 powers this or this. Immediately the K1 is powered, the main circuit is powered, the motor comes on. So after some seconds, the motor comes on. So that is just it. It's very simple. It's very simple. Now, we are going to modify this circuit. Maybe in another tutorial, we are going to modify it in such a way that as the timer is coming, as this guy is coming, we are going to interlock both the timer and the K1 and KIT. We are going to interlock K1 to KIT so that immediately this guy is coming on, this guy goes off to protect your timer, your fragile timer. So most of these timers, I will not mention them, but most of them are so fragile that they can be on the 24752 in a year and will not get spoiled. But they have the original ones that they can be on, they last very well for you. But most of these fragile ones that are cheap ones, and by the time you know it, after some, maybe last for you 1 year, it just gives up. So you find a way to protect the fragile timers, all those cheap timers. Okay, so I will show you how you can protect your timer from getting messed up and getting flashed, getting burnt, to protect your timer. Just a protection for the timer. Okay, I will show you how you use contacts to do that. If you have an additional contact, you interlock it. By the time you interlock it with this, with the normally close of this, interlock it here, you are good to go. So by the time you interlock this to this, use the normally close of K1, find the normally close on K1, maybe you have an auxiliary contact, or yeah, you still have an auxiliary contact of normally close, you interlock it here. By the time you interlock it in this place, just this point, as it's coming on, this one is going off. This one is going off, and it sustains. By that time, as this one is going off, you are also going to sustain this one with its own normally open contact, which is 13 and 14. So two adjustments is what we're going to make here. So we are going to demonstrate it not in this tutorial, but in another tutorial. I'm going to tell you how you can sustain, how you can interlock your timers. I think during the interlocking process, we are going to do that. I will teach that one during our interlocking topic, contactor interlocking. I'm going to show you that. Okay, but just to give you a tip on how you can do that, you just add a contact here, another contact here, which is 13, 14. Then you clean here up. You add another contact of this same contactor. So two contacts from this same contactor, 13, 14 of this contactor, and 11 and 12 of this contactor. So 11 and 12 here, which is normally closed, and 13, 14 here. You are good to go. That's the end of the story. You have conquered it. So 13, 14 here, on this place. Then you open here, you add 11 and 12. Open here, you add 11 and 12. You have interlocked the whole system. So immediately this guy comes on, this guy goes off, your timer is protected. So your timer basically have only maybe 10 seconds to work in the system as the system is counting. So it's only 10 seconds. The timer works only for 10 seconds. So the timer is off again, and the timer will be resting for the next operation. So immediately you call it up again, it works for only 10 seconds, the timer goes off, and the timer is resting. So by so doing, your timer will last for you. All these cheap timers, cheap ones, they will last for you. So that's why sometimes you find that people are using some cheap timers, and you find out how is this timer from year to year, nobody is changing timer. you know, the timer still lasts, and this is the secret behind it. Okay, when during our interlocking class, I will introduce that, then we'll do it. So let's go to the circuit board. So this, let's interpret it. Let's go and wire it there on the circuit board. Okay, so we are here on the circuit board. So let's trace our line. So from here, I have my 220 volts, which is here, 220 live. This is my fuse. So I have my 220 live, it's at 220 here already. So let me just show you. So this is my 220, this is my neutral. Okay, so 220 here goes to this place. So the first place the 220 enters, pass through the fuse, goes to 95, pass out of the 95, 96, so goes to 95. So let's go to 95 of what? The 95 of this. Okay, so it enters 95, and okay, so this is 95. It goes under the 95. So let's see, under 95. So let's start it. Okay, then comes out of 95. This is 95, comes out of 95, and goes towards to the one of S0. This is our S0 here. This is our S0, S0, X0. Okay, so this is X0, so it goes to X0. Then from X0, out of the X0, this is out of the X0. This is out of the X0. I don't know whether you're seeing what I'm saying. So this X0, it might not be so clear, but just follow my voice if you cannot see it. Okay, so this is out of the S0, combine to, goes to what? X0 comes out, S0 comes out from the 2 of X0, goes to what? To X1, 3 of X1. So 3 of X0 and X1 here, they are joined together. So there's a point here. They're joined together. So that means these two are joined together. These two wires are joined together. Look at it now. Then it comes out from here. So this, you can bridge from here. You can bridge them here. But I decided to bridge it here. Sorry. I decided to bridge it with this connector here. I decided to bridge it with this connector. Mind you, on that bridge here, this is where I tap my sustaining circuit, sustaining contacts, sustain contact, and goes sustain contact to timer, and then also tap it from there and goes to the K1 through via the contact of KI3. Okay, so that is it. Now it comes out. This is it coming out. Goes towards to 7 of what? Of the timer. Coming out, look at it, goes to the 7 of the timer. So I takes it, the 7 of the timer, with this timer, this is the 7. This is the 7. This contact is 7. So it goes to 7 of the timer. So I connect it to the 7 of the timer, which is the live. Okay, I will not connect the base. I will still keep the base on the table because everything revolves around this timer. Okay, revolve around this timer. Okay, so I will still keep it. Okay, good. Then from the 2 of the timer, from 2, which is 2, this is 2 of this timer, the 2 here of the timer connects to the 2, goes to what? To the neutral line. Okay, so I'll connect, goes to the neutral. Okay, so let's connect it. So connects to the 2 of the timer. Let's say 2 of timer. Then goes to what? So goes to, I didn't crimp this one, but it's okay. So it goes to the neutral. So look at, let's trace the neutral. This is the neutral. This is the neutral line. Goes, this is neutral line from the breaker, from the fuse cartridge. This is neutral line, goes down, goes down, goes down to this contact here. This is a neutral contact here. So let me just mark it. So it's a neutral contact here. So okay, so now it goes from this, from the base of the timer, and which is the number 2 of the timer, connects to this contact. Okay. So let me type it. Okay, it's fine. Okay, so we have done, then we have run it through straight ahead. Okay, we have run it straight ahead from here down, remaining this to sustain the timer with what? 1 and 3, with 1 and 3. So that means it goes to the 7 and goes to what? To X, to this place that it's at this junction where you have 2 and 3 of this switch joined together. So that's a common point here. That is where the 3 connects. So from the 3 of the timer, it goes to this common point. So then the 1 of the timer goes to 7. So I can loop 1 to 7, 1 to 7 directly without, I can loop it directly on the timer. So I can look for the smaller cable and loop 1 to 7 directly on the timer. Okay, so very simple. So let's do it. Make a loop 1 and 7. So I go to 7, I go to 1 again. Okay, so remember that 7 here is the coil of my timer. Then the 3 of the timer goes to a common point where you have this common point. That is where the 3 of the timer goes. So this common point, there's a common point here. This common point where you have the 2 switches joined together, the close, the stop button switch and start button switch, where they have the common, where the 3 and the 2 join together. They join together in this place. I use a contact here and join them together here. Then from the top of the contact, I get it. That's a common point there. Then I connect to what? To the 3 of the timer contacts, normally open contact. So I go to 3 and connect it to 3 of the timer. So I goes to 3, connect it to the 3 of the timer. Contact number 3. So our connection on timer is completed. So on the contactor, you have, it passes from, it gets power from there, and that is from the 6 of the timer, 6 of this timer, of this contact, 6 from this base is connected directly on what? On that same common point. On that same common point. Remember, you have a common point, and that common point, so you loop what? That common point is where you have 3 too. So you can also loop from your timer base. So let's understand what is going on here. So on that same common point, you have 3 of this timer there. You have what? You have 3 of the switch is there. There's a common point. Then you have 6 of the timer. So you can loop them together. You can loop this together. I don't know whether you understand what I'm saying. You have 6. This is 6 on this same common point here. Then you have 2 and 3 on this same common point. You have 3 of the timer on this. So 2, 3, 3, 6 joined together, you can loop together. So no matter how you loop it, they're the same. So I can loop 3 to 6 of the timer, then 8 goes directly to the K1 of my 8, KI8 goes directly to K1A1. Okay, so that's another loop here. So let's loop again. We'll continue to loop it. So let's loop again. So I loop 6 to what? I loop 6 to 3. 6 to 3. So I go to 6. Then I go to 3. So this is 6. My 6 here. So this is 3. Remember, there is no power. My 220 is off. Okay. This is another loop, so I have a loop like this. Okay. Okay, so, and mind you, this for the purpose of the tutorial. If it is normal wiring, you have to make everything look neat. You have a trunking, that everything looks very neat. So, but this is just for the tutorial, so it doesn't matter how you fly your wire. But on a normal panel wiring, you have to make everything looks neat. Put a trunking where you truncate all your wires. Okay, let me put it that way. Truncate all your wires. Okay, so that is it. This part is done. So now it's from 8 now goes to the what? K1. This is K1. This is KIT. This is the base of the timer. Sorry. This is the base of the timer. This is the timer fixing on it. So you fix the timer, this timer on it. So I just remove the timer so that I can be able to wire the base, because the base is where you do the connection. So the pin suits in, you see the pin, the pin enters. So that is just. So now it goes from what? KI8, the KI8 goes to K1A1. Okay, so KI8, where is 8? Let's look for 8. So this is 8 here. This is 8. On my 8, so it goes to what? K1A1. This is K1A1 here. So from 8 here goes to here. So this is how this one goes. So it will go like this, go here. So this one can go. So let's put this. Then goes to KA1. A1. This A1. So goes. Goes to A1. Okay, so now what is remaining goes to A1 of K1. Okay, from KIT8 goes to A1 of K1. Then the K1A2 goes to neutral. So remember, I have my neutral bar down here. I still have a neutral bar up here. So whichever way that suits me, I can put my neutral. So let me hang this. We're almost done. Okay, we are almost done with our connection. Okay, so now to terminate A2 down to neutral line. And that neutral line is where I have my 2. So I can also join the A2. I can loop A2 of this. I can loop this A2 of this one to A22 of timer. So I can loop this together. You can loop both of them together and give them one neutral. So there's a common point here. There's a common point here. They're on the same potential. So I can loop them together. So I can go from my timer straight to the contactor. So I can go. So this is it. Okay, now I go to 2. Okay, so 2, good. So I can go to 2 because they are in the same potential. So K1, A2, and the KIT and 2 are looped together, goes to neutral, common point. So I can loop it from the KIT just to make the job easy for me instead of looking for contacts to loop the neutral. Okay, so that is it. So they are looped. Okay, so it's okay. So let me just hang it. Okay, everything is wired and we are good to power it. Everything is here, so let's just insert our timer and let's power and see how this thing works. Let's give it a 10 seconds time delay. Then let's engage our power source. Okay, let's clear the road. Okay, so we are good to power it. So let's see how it goes. Okay, so the timer will start counting when I press on. Okay, the timer is on. I don't know whether you are seeing it. Okay, you can see the timer on now. The timer counts, the motor start running. I see the motor is running. Then so I can stop it from the contactor, from the overload. Then I can now press timer to start. Good. Okay, so that is it. That is self-sustained circuit latching operation with timer completed, done and dusted. Okay, remember, I can still pull it off from the overload. Something I did the other time, I just did like this. The motor starts running and this sustain, because the sustain is not from here again. The sustain is on the timer. The sustain, the contact of the sustain 13 and 14 here is not here. It's not connected here. So even if I press the contactor, it will just on. When I remove my hand, it will just stop. Okay, because the sustain is not there. If the sustain is there, immediately I'm pressing it, it will come on. Okay, we are almost to the end of this latching operation, etching and latching operation. So in our next tutorial, we'll move to what again? I think we're going to go to interlocking, or I will decide what we're going to do. So just the timer is on, and after 10 seconds, the motor kicks, the motor starts. Timer is on. Good. The motor is running. Okay, so after 10 seconds. So that is it. I start from here. Okay, so, and the overload indicators. Okay, so maybe in the next other one we'll start introducing overloads, and maybe we try to hold the motor as the motor is running. We'll try to, since it's a very simple motor, we'll try to introduce an overload to see how the overload is going to react, and just to hold the motor, maybe we'll try to clamp the motor, clamp the rotor of the motor, not to rotate. Then as the contactor kicks in, it will draw a very high current and overload, and it trigger the overload, and the overload will trip off the system and give us an alarm, or whether an indicator showing overload. I think we are going to stimulate that, and okay, that is it. Maybe we'll use a vice to hold the rotor of the motor. So we are going to stimulate it so that you see how the overload works, and the indicator, which should go to 97, 98. 97, 98 from here goes to this alarm here. So, and that is it. Okay, so I think we have come to the conclusion of this latching operation, introducing timers. In our next tutorial, we are going to do more on the forward and reverse direction of an electric motor, do more of interlocking. Yes, we're going to introduce interlocking, how you can interlock your contactors, your mechanical interlocking, and contactor interlocking, and rest of them, direct and indirect, reverser, those stuffs. We're going to do that before we go to Star Delta. Then we'll go back to Arduino program. I think after Star Delta, we'll go back to our Arduino program, interfacing it with whatever that we have learned. We're now combining to. So I started Arduino, I stopped at tutorial number 23, at tutorial number 24. That's where I stopped. So I will start this one, I will start to some point to start data, then I'll combine the both of them together. Then in that Arduino, I'm going to skip a lot of things in that Arduino so that, because I'm narrowing it to motor control. I'm using Arduino for motor control. That is just it for motor control, MC, motor control. So, and every other thing about Arduino program, maybe you can sort that one out. So once it gets to the motor control aspect of it, I think I have to stop the tutorial there. So every other thing you can maybe subsequent time, because there are a lot of things to do on this channel, on this program, on this platform. There's a lot of things to learn. So by special grace of God, we'll continue to move forward, continue to learn new things, continue to bring new ideas, and we'll continue to move forward. So thank you very much. God bless you. Your one and only Mr. Great here in Mr. Great Workshop. Welcome to Workshop. God bless you. Bye-bye for now. So